Hello. In this lesson, I'm going to be talking about partial fraction. Now, let's begin. Now, the idea behind what we're about to learn, which is partial fraction, is like a process by which you're trying to decompose fractional expressions to simpler fractions. I'll take that again, as a process of decomposing fractional expressions to simpler fractions. Now, to take that into a very small perspective, take for instance, you're trying to find the sum of 1/2 and 3/4. When you try to add this up, we're going to have a common denominator of 4. Then we have 2 here plus 3. This equals 5/4. Now, the 5/4 that we have here was the result of summing up 1/2 and 3/4. Now, we can refer to the 5/4 that we have here as a single fraction, and the 1/2 and 3/4 that we summed up has smaller, or we can call it simpler fractions. Now let's take it a little bit forward. If you have 1/x minus 2 plus 3/x plus 1, obviously, just like we did here, we have to find a common denominator, which is x minus 2, x plus 1. When we do that, we have x plus 1 here plus 3 times x minus 2. So we do have x plus 1 plus 3x minus 6 over x minus 2 x plus 1. Now this further simplifies to 4x minus 5 over, when you're trying to expand this, you have x squared minus 2x plus x minus 2. Now everything results to 4x minus 5 divided by x squared minus x minus 2. Now, this result of ours can be referred to as a fractional expression. As I have said in the beginning of this video, a fractional expression. Okay, and now this fractional expression came from smaller expressions, which is 1/x minus 2 and 3/x plus 1. These fractions, which came from this, are referred to as partial fractions. So what we are basically learning in this topic is the process of decomposing a much larger expression like this to simpler ones. There are 4 possible cases. You can have distinct linear factors, repeated linear factors, irreducible quadratic factors, and repeated irreducible quadratic factors. Considering the first case, which is the case where you have distinct linear factors. Now, this can happen when the denominator is a product of distinct linear factors. Now, this could be it could be 2 linear factors, it could be 3 linear factors, it could be 4, as many as possible. Now, let's look at the first example. We are to make a partial fraction decomposition of 4x minus 5 over x minus 2 times x plus 1. Now, since we have 2 linear factors here, which are x minus 2 and x plus 1, then we're going to split this up as a over x minus 2 plus b over x plus 1. Then we proceed to find the LCM. So we have x minus 2 times x plus 1. X minus 2 goes here, x plus 1, so we multiply that by a, x plus 1 plus b into x minus 2. That's equals to, when we try to split this up, we have ax plus a plus bx minus 2b divided by x minus 2 x plus 1. Don't forget that what we have here should be a product of 4x minus 5 divided by x minus 2 x plus 1. So which means we can say essentially that 4x minus 5 here is equivalent to 4ax plus a plus bx minus 2b. So I can write this as 4x minus 5 equals ax plus a plus bx minus 2b. Now, if they are equivalent, actually, then we can tag the identical sides of this equation. That is 4x minus 5 ax plus a plus bx minus 2b means that we can take the x that we have here, okay, and tag it along with the ax and bx that we have here. So we can say that 4, which is for the x, equals to ax, which is the a that we have there, then bx, then we pick the b that we have there. Okay, so this is for the x. And now for the constant, which are the standalone part in this equation, that is, they are the standalone variable, okay, not like ax and bx. So we have a and negative 2b. So this is going to give us negative 5 equals a minus 2b. So we can write it in the more conventional way, which is a plus b equals 4 and a minus 2b equals negative 5. So we have to solve this simultaneously. This is a, so we can just subtract this directly. Then this gives 3b equals 9. So that b equals 9 over 3. This is equal to 3. And you can substitute b into either of equation 1 or 2. So I'm going to take a plus 3 equals 4. That is from here. Okay. So I'm taking that to this part, substituting b to be equals to 3. So I have a equals 4 minus 3. A equals 1. So which means that the missing part here, which is a and b, have both been found. That is, a equals 1 and b equals 3. So we can take that back in here, and then we're going to have it as a, which is 1 over x minus 2 plus 3 over x plus 1. So in the second example, we'll have to first factorize the denominator as a product of two linear factors. So let's do that first. X squared minus 6x plus 8, x squared minus 2x minus 4x plus 8, x into x minus 2 minus 4 x minus 2. So everything simplifies to x minus 2 and then x minus 4. So therefore you can rewrite this as 8x minus 28 divided by x minus 2, one form, and then x minus 4, which is the other form. So this equals, because we have two linear factors, then it means that we are breaking it into two partial fractions, a over x minus 2 and b over x minus 4. Now what we have to do here is to find a common denominator for this, which is x minus 2, x minus 4. So we have a into x minus 4 plus b x minus 2. This can further be expanded as ax minus 4a plus bx minus 2b over x minus 2 x minus 4. So bring it out along with what we have here, which is 8x minus 28. Then we can say that 8x minus 28 equals ax minus 4a plus bx minus 2b. Let's bring the x's together. The x we have on the left hand side of this equation can go along with the first x we have here, which is ax, and the second x we have here, which is bx. So we can say that 8 equals a plus b. That's like the x family. And the second part, which is the constants, which is the negative 28 that we have here. So we have negative 28 equals, we have a negative 4a, and we have a negative 2b. So this means negative 4a minus 2b. So we can multiply through by negative in the second equation, so that we have 28 equals 4a plus 2b. Now we call this first one equation 1, and we call the second equation 2. So 4a plus 2b equals 28. So we can try to eliminate b by multiplying equation 1 this by 2, so that we have 2a plus 2b equals 16, and this multiplied by 1, 4a plus 2b equals 28. So when we subtract that, we have negative 2a, which is 2a minus 4a is negative 2a, equals negative 12. So a equals 6. Taking that back to the first equation, now that we know that a equals 6, then we have 6 plus b equals 8. So b equals 2. Now we can take that back to the starting point. So therefore the a over x minus 2 plus b over x minus 4 equals a 6 over x minus 2, and b now is 2, which is over x minus 4. Now, while solving problems like this, you can always take your time to check if your partial fraction is the same as the starting single fraction. That is, when you try to simplify this, when you try to bring it together, it must be the same as 8x minus 28 over this. So we can take our time to do that. Let's do that real quick. So the LCM here is going to be x minus 2, x minus 4. Now we have 6, x minus 4 plus 2, x minus 2. So this equals to 6x minus 24 plus 2x minus 4. We can expand this as x squared minus 2x minus 4x plus 8. Now this equals to 8x minus 28 over x squared minus 6x plus 8. This basically is the same as the original single fraction that we came from. So you can always take your time to check if your partial fraction is the same as the single fraction. So in this case, we have three linear factors: x plus 1, x minus 3, and 2x minus 1. And that's why it has been split as A, B, and C. So we know by taking the common denominator and all that, this is going to be ignored, and this will be multiplied by A. So we have A times x minus 3 and 2x minus 1 plus, then B, x minus 3 goes, so we have B x plus 1, 2x minus 1. And for C, this must be equivalent to 3x squared minus 4x plus 5. So let's break this down. All right, so we have A x minus 3, 2x minus 1 expands to A 2x squared minus x minus 6x plus 3, which simplifies as A 2x squared minus 7x plus 3. So we're going to separate it this way as 2a x squared, right, minus 7ax plus 3a. For b, we do the same. B x plus 1, 2x minus 1, just b. We have 2x squared minus x plus 2x minus 1. So that simplifies to, b 2x squared plus x minus 1. So this equals to 2b x squared plus bx minus b. Lastly, c x plus 1, x minus 3, this equals to c. Then we have x squared minus 3x plus x minus 3. So this goes to c x squared minus 2x minus 3. This simplifies to c x squared minus 2cx minus 3c. So we are matching everything we've written here with 3x squared minus 4x plus 5. So let me just put that here. So this goes to 3x squared and all of this goes to negative 4x, and all of this goes to 5 by comparison. So I'm going to pick that one by one. So we're going to have 2a, 2b, and cx squared, all joined by addition. So we have 2a plus 2b plus c equals 3. And for this, we have negative 7a, b, and then negative 2c. So we have negative 7a plus b minus 2c equals negative 4. And lastly, we have 3a minus b minus 3c equals 5. So we're going to try to solve this. This is a 3-system equation, and we'll have to first reduce it to a 2-system, then 1 system, which is linear, and then we solve it. So we're going to start with I'm going to take equation 2 and 3. I'm going to try to eliminate b. Okay, so negative 7a plus b minus 2c equals negative 4, and 3a minus b minus 3c equals 5. So to eliminate b, I can just add both equations. So I have negative 4a, negative 5c equals 1. So on one side we have 4a negative minus 5c equals 1. So next thing I'm going to do now is I'm going to combine 1 and 2. 1 and 2. So for 1 I have 2a plus 2b plus c equals 3. And for 2 I have negative 7a plus plus b minus 2c equals negative 4. So to eliminate b, in this case, we have to multiply the second equation by 2. So I have 14a negative plus 2b minus 4c equals negative 8. So when I try to combine both 2a, 2b, and c equals 3 with 14a negative plus 2b minus 4c equals negative 8. So here I just have to subtract because they have this different the same sign. So this is 16a, and this is going to be plus 5c, and this equals to 11. So I'm going to put that side by side with this. So 16a plus 5c equals 11. So to eliminate this is negative 5c and this is positive 5c. So we just have to add it up, and this goes to just 12a, 0, and this equals 12. So a equals 1. So I'm going to take the a and substitute it to this equation here, which is negative 4a plus minus 5c equals 1. So I have negative 4 times 1 minus 5c equals 1. So this is negative 4 minus 5c equals 1. Negative 5c equals 1 plus 4. So this equals 5. 5 equals c equals negative 1. So the last part is for b. We can take any of these 3 equations and try to plug in the value of a and c. So I'm going to use the first equation again, 2a plus 2b plus c equals 3. And so a is 1, so 2 times 1. B is what we are looking for, and c is negative 1 equals 3. So this is 2, 2b minus 1 equals 3. So we have 2b plus 1 equals 3. So 2b equals 2 and b equals 1. So from all we've done now, we can see that a equals 1, b equals 1, and c equals -1. So this single fraction can be decomposed as a 1 over x plus 1 plus b is 1, so 1 over x minus 3, and c is -1, so we have minus 1 over 2x minus 1. Now this is just one of the numerous methods you can use to solve this equation 1, 2, 3. You can use the cover-up method, which I'm going to cover in the next slide. Now to the cover-up method. The cover-up method basically has to do with taking a linear factor one at a time and set the value to be equal to 0. So for instance, I'm going to be taking x minus 3 to be equal to 0. So x minus 3 goes to 0, which means that x must be 3 for this statement to be true. And I'm going to plug x equals to 3 into each time x appears here. So we have a times 3 minus 3 times 2 times 3 minus 1. For b, I have 3 plus 1, 2 times 3 minus 1, and for c, I have 3 plus 1 times 3 minus 3. This equals to 3 times 3 squared minus 4 times 3 plus 5. 3 minus 3 is 0. 0 times a, 0. 0 times this, 0. So everything here goes to 0. The same thing goes with c. All of c goes to 0 as well. So we are left with b multiplied by 4 times 5 equals, here we have 27 minus 12 plus 5. So this is 20b equals 20. So b equals 1. We're done with the value of b. Now we have to set another linear factor to 0. This time I'll be picking x plus 1. If I set x plus 1 to be 0, x will be equal to minus 1. So we go again. I will have to set x minus 1 for each of the values of each of the times x appears here. So I can put it here. I have a times -1 minus 3, then 2 times -1 minus 1. Obviously, if you do the same here, b goes to 0, and if you do the same here, c goes to 0. So this equals to 3 times -1 squared minus 4 times -1 plus 5. So we have here we have -4a times -2 minus 1. This equals 3, because -1 squared is 1, so plus 4 plus 5. So -4a times -3 equals 12. So this is 12a equals 12, and so a equals 12 divided by 12, a equals 1. Lastly, we have to set 2x minus 1 to be 0, 2x minus 1 to be 0, so that will make x to be equal to 1 over 2. Plug that in every point where you have 2x minus 1 and then you have 0. So which means all of this goes to 0, all of A goes to 0, all of B goes to 0, and then we are left battling with C. So C multiply by half plus 1, then half minus 3 equals 3 raised to the power of 2 minus 4 times 1 half plus 5. So this is 3 over 2. This is negative 5 over 2. This is 3 over 4 minus 2 plus 5. So this gives negative 15 over 4c equals 3/4 plus 3. So negative 15 over 4c is equal to 3/3. Negative 15 over 4c. This is 15 over 4 as well. So when you do that, we have c equals negative 1. So you can choose which of the method you think you find convenient to use, the cover-up method or the full expansion method. In this problem, you will notice that the degree of the numerator and that of the denominator are basically the same. That is the highest degree. Here we have x raised to the power of 2, which is degree 2, and at the bottom we have x raised to the power of 2 as well, which is also degree 2. And this is one of the things you have to look out for when you are trying to resolve into partial fraction, that the degree of the numerator must at all time be less than that of the denominator. Now, let's say that the degree of the numerator and that of the denominator are the same, or that of the numerator is greater than that of the denominator. Take for instance, one is 2 and the other is 2. Then in this case, you have to make a division, just like you're about to see. And the same thing goes with this. If you have a degree 3 numerator, that of denominator is degree 2, then there has to be some sort of division to reduce this to something that can be resolved. Take for instance, so we have a 7 over 2. We know that there are two parts to this. We have the whole part and the fractional part. So this is what is happening here as well. We have to reduce this to the whole part and the fractional part. Now that fractional part is going to be what we're going to resolve. So which means we're going to perform a division. 4x squared plus 9x minus 73, and here x squared plus x minus 20. So the divisor, the dividend, and we'll see the quotient. X squared divides 4x squared. This is 4 times. Now this goes back to multiply each of the terms you have here, which is 4x squared plus 4x minus 18. So we perform a subtraction there. 4x squared minus 4x squared goes to 0. And this is 5x plus 7. We can no longer divide this because the remainder is less in degree than the divisor. So we'll have to stop here until we have the 4x squared plus 9x minus 73 divided by x squared plus x minus 20 been written as 4, okay, which is the whole number, plus the remainder after you must have divided it by this. So now this part is what we are resolving into partial fraction. So basically, I have 4 plus 5x plus 7 divided by, now when we try to factorize this, we have x plus 5 and x minus 4. Now when we try to split this, we have two linear factors. We have an a over x plus 5 and a b over x minus 4. So don't forget that we are taking this together with 5x plus 7 over x plus 5 and x minus 4. So a multiplies x minus 4 and b multiplies x plus 5 equals 5x plus 7. So I'm going to use the cover-up method to make it quite fast. I'm going to put x to be equals to 4 to make this go to 0. Okay, so I have b 4 plus 5 equals 5 times 4 plus 7. So this is 9b equals, everything here sums to 27, and b equals 3. So I'm covering b now this time around, so I'm making this 0, so I'm substituting negative 5. X equals negative 5. So a negative 5 negative 4 equals 5. Negative 5 plus 7. Sorry about that. So this is negative 9a equals negative 25 plus 7. So negative 9a equals negative 18. And so a equals 2. Okay. So therefore, this can be written as 4 plus a is 2 over x plus 5 plus b 3 over x minus 4.